Alright, today we're going to talk about resistors. So what we know so far is here's the symbol for a resistor. So anytime you see a device with that as part of its symbol, you know it's going to be some type of resistor. So resistors, as we know so far, are rated in ohms. So they all have some specific level of resistance, some predetermined opposition to current. The other rating that resistors will have is a rating in watts, which we just recently learned is power. So the power for a resistor is basically an expression of how much heat it can dissipate. Remember, watts and power is usually the rate that energy is consumed. So when we deal with wattage on a resistor, it's how much heat it can dissipate. The higher the wattage, generally the higher the current that resistor can handle. If you exceed that and you put too much current through a resistor that is not designed to handle, it burns up and smells bad. It's going to happen to you sometime. So the two ratings you need to be concerned with are watts and ohms. What that wattage usually means is I have a physically larger resistor as I get larger wattages. So like the resistors you guys use in class are about that size. So you're looking at 1/2 and 1/4 watt resistors. You know, if I get a 1 or 2 watt resistor, it might be physically that size. The larger physical size doesn't mean anything for its ohms rating. It's just the wattage, how much current it can handle. All right, the first of the resistor types that we're going to look at will be this guy with 2 arrows pointing towards it. So if I have 2 arrows pointing away from a device, such as an LED, it means it gives off light. In this case, I have 2 arrows pointing towards the device. It means it's going to react to light. So what we have here is a photocell. Photocell is a photoconductive device. Told you that word was going to come back. The symbol you may see with or without a circle around it. So the circle doesn't mean anything, it just depends who and how it was drawn. So a photocell, its resistance changes based on light. So most of them, as light increases, what you're going to discover in the lab is what is resistance going to do. Is resistance going to increase or is it going to decrease? Most of these are going to be inversely related. So as light increases, resistance decreases. And so as light decreases, resistance will increase. Photocells themselves usually look like a little cylinder with a squiggly line on it with 2 leads. Being a resistor, it doesn't matter which lead is positive or negative. Current can travel through this thing in any direction. If you have a dusk to dawn light anywhere in your house, somewhere on that light will be a photocell. That's the way it knows whether it's light or dark out. So a photocell is simply a resistor whose resistance changes based on the amount of light that's striking it. Next up, we have a device called a potentiometer. So now I have the resistor symbol, but only with a single arrow. What a potentiometer is a variable resistor. So it's going to look like a knob or a dial that I can adjust. So a potentiometer, as you guys will use it in the lab, is 100 kilo ohms from the outside to the outside. Because if I think about it, there's a straight path through that resistor that would give me 100 ohms or 100,000 ohms. But the potentiometer is adjustable. So that adjustability comes between the middle and one of the 2 sides. So between this middle lead and this side here, I could have a value anywhere between 0 and 100K, depending how I adjust it. So the same holds true for the other side. It's going to be anywhere between 0 and 100 kilo ohms. So in this case, I have a path through part of the resistor and out the middle lead. So depending on where that middle lead is adjusted determines how much of the resistor it actually travels through, depends how much of that 0 to 100,000 ohms we actually place. So a potentiometer is just a variable resistor. What it's going to look like most of the time in the lab is I will see sort of a circle with a knob, and then it has 3 tabs sticking out the top. So if I number off my tabs as 1, 2, and 3, we need to match that to our symbol. Final resistor type looks like this. I have a resistor symbol with what kind of looks like a check mark going through it. And so those are known as thermistors. So thermistor, you read into the word. I have thermal. So what I have is a temperature-based resistor. Its resistance value will vary based on the temperature that it's exposed to. So thermistors in our lab have what's known as a negative temperature coefficient. So a negative temperature coefficient means that as temperature increases, resistance will decrease. Likewise, if temperature decreases, resistance will increase. So they're inversely related. Thermistors will often look like a small cylinder with 2 leads sticking out. And so thermistors are coded one of 2 ways. You may see actual colored bands on it that mimic the resistor color code that you actually know. What you may also see is on that face, you may see a number like 104. And so what that number tells you is the value of the resistor in the same way that the color code does, and that the first 2 numbers give me the first 2 digits. So I have a 1 and a 0, and the 4 is the multiplier. Add 4 zeros. So in that case, a 104 would be a 100,000 ohm thermistor. So the 100,000 is its temperature, or is its resistance at room temperature. As its temperature then increases, its resistance would drop from 100,000.